All right. Well, the last one that we have is the area of a segment. Now, these two formulas you will be given. Okay. You have to know the stuff from yesterday. You have to know how to compute arc length using whichever proportion or formula that you prefer. There's several different ways to approach those. You need to know that. Areas of segments, since it's so similar, you need to know how to do those. But for the test at the end of the week here, I will give you both of these two formulas for area of a segment. Now, there's two ways that the dimensions of an area of a segment can be given. One way, no matter what, we have to know r, the size of the circle that we're dealing with. But one way to find the area is if you know h, or in other words, the depth of that segment. The other way is if you know the size of the angle that subtends the arc. So, if we have a circle and we have a chord which chunks off some segment, no matter what, we have to know what the radius of the circle is. That's absolutely given. And then the other thing that we need to know, we either need to know how wide the angle is to form that arc, or we need to know how deep into that circle that segment extends. As long as we know one of the two, we can find it. How would you find this area if we didn't have a formula? Well, could you find the area of the sector? You could. Can you find the area of a triangle? Yeah. So how can you find the area of a segment? Subtract off. So if you can write a formula that finds the area of a sector and subtracts off the included triangle, you'll get two different versions of that.
Is the bottom one in radians?
The bottom one is in radians, yes. The bottom one, theta, has to be in radians. Here's what we've got. We've got a piece of round stock, and if you've ever worked with any type of mechanical equipment, oftentimes if there's a round shaft for transmitting power like on an engine or electric motor, one side of it will be ground flat so that whatever device is attached to it can be clamped on and not spin around. But here's what we've got. We've got a piece of 1.5 inch diameter round stock, and we're going to grind it flat on one edge. We're going to remove a 1/4 inch of the stock. That is, we're going to cut a 1/4 inch of the way in. And the question is, what is the cross-sectional area of the piece that's left? So if we were to look at that head-on, we'd see that. It's not a half bad circle, is it? It's pretty good. So here's what we got. So going back to the previous screen, obviously which of the two formulas for segment area are we going to use? Top one, because we know h. We know how deep the segment is. So the only other dimension we need to know here is the radius. The stock is 1.500 inches in diameter. That means its radius is 0.750 inches. And from there, we can proceed. We are finding this area. So, just a matter of using the formula. That area is going to be given by Yep. It's a doozy. That's right. Yep, this is going to give you a ratio less than 1. And you're going to take the inverse cosine of that. Again, it's important to note here that this has to be in radian mode also. Because when you take the inverse cosine, it's going to produce a result either in radians or degrees. Your calculator has to be in radians for this to work. Both formulas, it's important to note that both formulas assume that our angle is in radians. Yep, dimensionless. Okay, so then it's just a matter of plug in. A is going to be our radius is 0.7. I'm going to leave the units off of this just to save a little space. Squared times the inverse cosine of I'm just going to give you a minute to crunch that through on your calculator. It's a little bit ugly, and I want to make sure that you're getting that to work out. The left half, 0.75 squared, the r squared arc cosine of r minus h over r should turn out to be 0.4731. The right half of that mesh should be 0.2795. Yeah, and if you subtract that, you end up with 0.1936. Now, what would your units on that be in this case? Square inches, that's right. It's an area, and our units were in inches. So we found the area of the segment. Again, leaving plenty of sig digs because we still haven't actually answered the question. We have one more minor step after that. Does that look good up to there? We got that to work out? The question was, what's the area of the remaining stock? We actually want all that. So we just need to take the area of the circle and subtract that off. So this area is going to be pi times the radius of 0.750 inches squared minus 0.1936 and the area turns out to be, all the dimensions were given to the nearest thousandth. We'll follow that, 1.574 square inches. And that takes care of that. Okay, well, let's look at one more. Questions about that one before we leave it? Okay, let's do another one here. We've got a circle, and there's an arc on that circle that's 1/4 of the circumference of the circle. That is to say, 1/4 of the distance around. We connect the ends of that arc with a cord and then chop off that little segment. We want to know what the area is. Now, do we know how deep that cut is? Do we know how deep that segment is? We don't. So we're going to have to use the other formula. Since we don't know how deep it is, we better know how large the central angle is that subtends that arc. Well, if it's 1/4 of the circle, that has to be, of course, How much? 90 degrees. 90 degrees is all well and good, but our formula requires that this be in radians. You should know what 90 degrees is in radians without having to convert. We know that that is pi over 2. Excellent. Pi over 2. So our area of the segment is equal to, go back, use our formula given if the central angle is known, and that is 1/2 r squared times theta minus the sine of theta. So in our case, our radius has got to be 2.25 meters. Theta is pi over 2 minus sine of pi over 2. Again, got to be in radians for any of this to work out. Incidentally, what is sine of pi over 2? You don't need your calculator for that. You might type it into your calculator and then go, oh yeah, of course. But what is the sine of pi over 2? 1. Sine of pi over 2 is 1. And if you crunch that all out, you end up with, anybody got it? 1.44 meters squared, and we're done. It's worth noting a problem that we can't solve at this point. A problem that we can't solve, usually it's nice to take a formula and have different parameters missing, so you have to rearrange. But if we were told that we had a circle of diameter 4.5 meters and we wanted to find a segment with an area of, say, 2.0 square meters, we couldn't do it. We'd have to be solving for an angle theta. If we don't know this angle theta and we know what the area is, we'd have to work backwards. But we've got theta showing up in two parts of this formula, and we don't have the algebra yet to combine those into one. So at this point, that's the only direction that we can work that problem. We can only use it to get an output value, which is good news for you, but disappointing because I know you want to work it through both ways. So that's it. We're done. Area of a segment, using a formula. Question about any of the computation here? Did everything work out all right? Good?